Today we're looking at a Samsung SDI module that I use in a product that I sell. And these have actually been recalled, and Samsung has not provided a lot of guidance to small users. Automotive users, I'm sure they have. I am not a large-scale automotive user. I'm using on the order of 500 of these modules, whereas a manufacturer might be using 10 million of them. So I'm pretty small fish, but I've not been able to find a lot of information on these modules. So I figured I would just film a video here real quick describing the teardown and the recall. Mostly the teardown in this video. This is more for a general audience that might have just come across this module and just be curious what's inside of it. So I have taken one apart. I do not recommend doing this without proper training, etc. These cells are fully discharged. This module that's taken apart, I've actually been using in my product for over 2 years at this point, and I had no problems with it whatsoever. But as part of the recall, I needed information on modules that I knew were good, or at least hadn't caught on fire, experienced a thermal event. So we're gonna look inside. I'm gonna take this prop module out. This is kind of what they look like when they're still assembled. These are known by lots of different names. I call them 47 amp hour modules because the ones I use are boilerplate rated to 47 amp hours, but you'll actually find that the same modules, depending on the manufacturer specification, are specified from, I've seen that down to 39.5 amp hours all the way up to, I believe, 49 amp hours. So quite a big range, you know, a 20% range that they're spec'd at. And that just has to do with if a manufacturer comes in and says, I need you to tell me the number of amp hours when I'm discharging it at 50 amps, or someone else comes in, I need you to tell me the same at 10 amps discharge or 100 amps discharge. You can play around with the number of amp hours because the number of amp hours is typically determined at a very small value, but a lot of automotive manufacturers require the cell manufacturers to give you amp hours at a very high load, like 50 amps or 100 amps. But typically, if you're the manufacturer and your customer doesn't specify what discharge current they want their amp hours at, you're gonna go as low as you can, you know, maybe even down to like C over 100 because you're gonna get a much higher value. And so that's why the range varies again from like 49 amp hours all the way down to maybe 39.5 amp hours that I've seen. I call them 47 amp hours because that's how I first fell in love with them. Other names are LX68 modules. I had previously called these just generic Fomaco modules, but we don't do that anymore. That's just because that's the first car that we found them out of. This particular variant is rated for 2.07 kilowatt hours, but as we look inside here in a second, you'll see that the actual per cell boilerplate rating is quite a bit higher. So anyway, we're gonna take this module apart, which I've already done. So let me get this prop out of the way here, safely stored. Okay, so this module weighs 26 pounds. Again, it's 2 kilowatt hours. It's got some pretty high density. It is under an enormous amount of pressure. Getting this case off was quite difficult, and these cells are all discharged, so don't worry about the concerns there. They're fully discharged down to 0 volts. So there's basically no risk that there's no energy left in these cells. So anyway, I cut this in half right here with just, you know, that. And again, this was a recalled module. It had no issues beforehand. I've been using it in my car for 2 years, probably more than 2 years at this point. This was the first alpha unit. And I just kind of wanted to talk about what I saw inside. One of the things that prompted me to look inside of here was bulging we were seeing on this end plate here. And as you can see, these modules are under tremendous pressure. You can see how much they've ballooned out. That happened immediately. Lithium cells, especially these higher energy density cells, need to be under compression if they're non-cylindrical. So if you have a prismatic or a pouch cell, especially pouch cells, they do need to be compressed. Now I can kind of compress this, but I mean, this is a lot. I mean, I can actually feel it bowing in when I do that. These are under enormous pressure. So we were actually seeing this aluminum plate buckle slightly. And I was actually able to find in a data sheet that I got a hold of that Samsung appears, this is my interpretation of their specification because it's pretty open in its spec, but it appears that they allow these plates to deflect 5 millimeters maximum, and that would signify end of life due to swelling. None of the modules, I have 220 of these in my inventory right now, None of them that I looked at were anywhere close to that. They were approaching 1 millimeter of deflection, but I think that might be per side. So the 5 millimeter spec they get, I think, is the total elongation. So I think you get 2.5 millimeters per side. Now, in my testing, I looked at 220 modules. I inspected 440 end plates, and they were all between 0 millimeters and 1 millimeter of deflection. Now, some people have reported seeing these with closer to like 1.5 or maybe even 2 millimeters of deflection. But again, that would be in spec, I think. I think Samsung spec is 2.5 millimeters deflection on the plate, you know, holding a flat edge to this when it's assembled. When this is assembled, this is sitting in here. And so this steel piece on the outside here, basically the way they assemble this is they have some machine that's compressing this aluminum plate, and it's got some fingers. It might go through these bolt holes here. And then they actually weld this chassis around it. So you can see the weld seams here. These just keep this thing in compression. So all that force is on here. And when you cut that last little snip here, this flew open. You know, I was wearing gloves and safety goggles and all that jazz. But looking at the modules themselves, they're very well protected. You can see I did a little bit of damage to them in my take apart haste here. Again, they're discharged, so there was no harm there. And of course I wasn't gonna put this back together. So I just wanted to get inside. But you can see the deflection these modules have. When these are compressed, you know, they're probably a few millimeters compressed a piece. You can see it here. Just look at how much these, I haven't cut the tabs on these. And look how much they're bowing here, right? These cells are really pushing apart. So the deflection on the plate here, again, I found that spec in the spec sheet today that I wrote about the 5 millimeter deflection. It makes sense that this is deflecting. There's an enormous amount of pressure on these cells. So when you cut that and these start bowing here, that's what these end plates are resisting. And you know, you can really push on them there. I'm not a weakling, and you really can't get these back down. So this is hundreds of pounds of force, maybe even 1,000 pounds of force. I have no idea. So again, I'm not surprised that the plates deflect. It would appear that because Samsung specifies an end-of-life limit for that deflection, or they call it elongation, but they don't actually specify what that is, it would appear that this is something Samsung's very well aware of. So I don't think we need to worry as much about this aluminum end plate deflection. Obviously, if the module is deforming, you would be above the, if the aluminum has run into the steel piece here, you're probably at that 5 millimeter limit. So anyway, yeah, just kind of looking at the module again, it's very well designed. The energy density they have here is just insane. They have a mica sheet, so I use a mica sheet in my product. And I actually had a couple people ask me, like, do you think that mica sheet would actually do anything? And I did some testing to, when I put it in my product. I've got a 14 by 14 inch sheet of mica. Seeing it in these modules means that yes, it probably does something, because this mica is not expensive, but it's also not cheap. And I think I pay in small quantities, probably $5 to $6 a square foot for it. So there is an additional cost for having this sheet. So yes, it obviously is doing something, or Samsung wouldn't be putting in here. They literally have it between every single module. They basically have a glue layer, and you can see this is just it's probably actually a tape. They put a tape down, they put the mica down, they put another tape layer, and they stick another cell on. You can see there's one layer per cell there. So yeah, they are using mica, so I'm glad I have the mica in there. Cells are well designed. They're very well insulated. I am going to come in here. The actual recall is inside of the cell. The separator between the anode and cathode is failing for reasons that Samsung in their official literature does not understand why. And that's why I have a lot of doubt that Samsung has actually been able to fix an issue, because they don't know what the issue is. So they've mentioned they've done a lot of process improvements, including X-raying, per cell, optical inspection, etc. But if you don't know what the actual root cause is, it's hard to fix a problem if you don't know what the problem is. So if you do something and the problem goes away, obviously that's one thing, but this failure rate is very low. My estimate, which again is my own opinion based on the data I've seen, is that 1 in 8,400 cells are impacted by this issue, this failure. Now Samsung has recalled, I believe it's close to 20 million cells. So that's a lot. That's going to be a big financial hickey for them. I mean, they'll live through it. Samsung SDI's big player in town, but this is also one of their, you know, big modules. These are in Ford, Audi, Volkswagen, Jeep, you know, the Wrangler 4xe, etc. So these are those modules that have had failures. These have had a couple failures. The first one was that these bus bars weren't welded well. The machine was not calibrated properly or something. This was maybe 2022, maybe late 2022. That I shrugged off in my case because these are rated for, and this is just, you know, I don't actually know the number off the top of my head, but I think these are rated for something like 300 amps of discharge for maybe 10 seconds or something. In my application, it's never more than like 140 amps. So I was way below that. I didn't care that much about the bus bar issue. Again, these rings where they were, you know, tab welding these on were not done well. Notice they're not soldered. I'll just throw that in there for my longtime viewers, because real lithium batteries are not soldered together. You have some kind of tab welding. But anyway, we don't need to get down that can of worms. Ultimately, you know, this module is put together very well, and having now looked inside of it, yeah, again, this 1/4-inch plate here, flexing. I mean, I of course can't flex this with my hand, but I mean, God, look how much pressure that it takes to even bend it. You know, I could get the arbor press in frame. You know, I might as well, because I don't really have any point to this video, and the arbor press is just sitting right there waiting to crush things. So I'm gonna just, this is not scientific in any way. I'm gonna take this rotary off here, and I'll probably put this here because I think there's going to be a lot of force here in just a sec. This plate has 2 little legs on the bottom. I just kind of want to see the amount of force. I think this is a 2-ton arbor press. Let's get that arm out to crank in mode. So yeah, it's a lot of force. I would say, based on my experience with this thing, that's probably around 1,000 pounds of force to get a millimeter of deflection. Very ballpark. No strain gauges on here. The strain gauge is just on my arm. So, but that feels about right. Point is, there's a lot of pressure on these cells. So yeah, that is the inside of these modules. Oops, I just dumped a box of stuff. Biggie. That is the inside of these modules. I'll just kind of show what's in here. This is an electrical insulator here. It's very, very thick. It's actually a little difficult to cut through with scissors. It's, I don't have my calipers, but probably 50 or 60 thou. It's quite thick. And this has good coverage on the sides. It rolls over really well. And then of course, every cell is also fully insulated. So you have a double insulation here. This one's a little bit thinner of an insulation. And then you have the mica sheets that are both a thermal and an electrical separator. Let's see if I can get one off in one piece. Yeah, those are definitely taped on, not glued. So yeah, there's our mica insulator. Yeah, so anyway, I'm gonna play around with some of these, probably puncture that, see how much force it takes. I definitely wanted to look at impact force. This guy actually had a dent in it, and I still threw this in my, again, my Alpha car. I would never have sold this to a customer. But I had this in my Alpha car for 2 years. The dent is definitely feelable on the inside, and the orientation was there. So this is that side, and we were pretty close. So we were actually, I'm gonna have to actually do math here because I don't want to get this wrong. I can use a metal tape measure because these are all discharged. Okay, so from the end plate-ish, we are approximately 24 millimeters. I think that's going to be right between the cells. So that would be, this I did with the flathead. 24 millimeters. Actually, no, it's kind of right on the edge here. So if there had been damage, we would have seen it here and it would have been low. In fact, there is the damage, yeah. So this amount of damage here, that depression, which was a pretty good hit, actually did dent this cell. I hadn't actually looked at that before. You can see there's quite a bit of denting there. I don't recommend, if there's any denting in the cells, I do not recommend using them because that can cause the same separator failure. But again, I used this in my car for 2 years. My car has the absolute runt 5 modules, and it had the 5 runts before, and now I've put the 5 worst performing modules out of the 220 I just looked at in there again. I hope I don't eventually burn the car to the ground, but I'd rather burn my car to the ground than yours. So I'll do that testing on my end. But yes, it does appear that if you have questions, is a ding bad? That ding is bad enough, sample size 1. If it had been a few more millimeters that way, it would have been between the two and maybe it would have been okay. But yeah, any dings you see in the black, especially on the bottom of these modules, that's going to be kind of game over. These bottoms, there's nothing to remove here. If you actually look at the stock module, let me grab it again. Oh wait, I've actually put rubber on here. The EPDM rubber on the bottom is something that I added, but you can actually see the module sticking out here. So this whole piece is stuff I've added with a little bit of junk there. But yeah, this is not there by default because Samsung expects you to mount this onto a flat plate. And they actually have a specification in their data sheet that says if that plate is not flat to within, I believe, 0.5 millimeter, then you need to put an electrical insulator there because otherwise you don't have that double insulation from that high voltage battery. So yeah, otherwise I'm gonna just kind of show things. Oh, I did want to mention that the individual cells are rated for 178 watt hours a piece. That might be too bright, but if you look right there, 178 watt hours a piece. So if you multiply that by 12, I don't do math in my head, sorry, but and I don't have my calculator right here, so I'm gonna have to use my phone. But if you do 12, because there's 12 cells, and then there are 178 watt hours a piece, that is a 2.136 kilowatt hour pack. So 2,136 watt hours. Again, they rate it to 2.07, so 2070 watt hours. So it's actually quite a bit more if you subtract that out. Again, I don't do math in my head, but it's 66 watt hours more, which is about the size of a, the battery in like a MacBook Air circa 2016. I haven't looked them up in a while, but batteries in laptops are, I don't know, 100 watt hours. I think some of them nowadays are pushing 200 watt hours. So each one of these cells is giving up maybe a third of a high-end MacBook Pro's battery and capacity. So there's a lot of capacity on the table that's not advertised here. And again, that's probably because Ford, who I got these modules from, probably specified a capacity at a certain discharge current, again, like 40 amps or something. So they got a slightly lower value, whereas the one on here might be discharged at 1 amp over the period of 2 days or something, 47 amp hour battery or whatever. Anyway, I believe Audi might have the higher spec because I think theirs is the 39.5 amp hour rating. Again, all 3 of the sizes I've seen, 39.5, 47, and 49.5, I believe, those are close enough. In my testing at some discharge current, I don't know, 1 amp, I don't remember what it is, but they all have exactly the same capacity. They're all exactly the same modules. They're literally just the sticker that Samsung puts on them because they're specified one way or the other. And that's really evident in the fact that this recall affects 4 different automotive manufacturers. Same cell, same manufacturing defect, or design defect even. No one knows what it is, at least according to public information. I have reached out to Samsung. I don't expect to hear back from them. I haven't really yet. Typically the way that works is they say, oh, you're some dude in your garage. We're not really that interested. That is one of the things I actually miss from being in industry, is that when you are from a large reputable company and you contact another large reputable company, they typically get back to you, because if they don't, then you could switch to someone else and they would lose millions of dollars. Whereas with me, I'm buying second source modules. They don't make any money on me at all. I'm just some dude, again, in a garage, making a project, having a fun time doing it. As much as it sucks that these have been recalled for my product, ultimately, I think that it increases the risk slightly. Samsung is doing ASIL D level design, which is the most difficult to meet. And that's because people, driving Jeep Wrangler 4XEs or Ford whatevers, they're parking these in the garage. They're not in a beta program. They want the car to work. They don't understand the risk necessarily that they're under. Whereas my customers are all beta testers, and I specifically prohibit, putting this in the car that this is inside of a habitable space. So I only go to ASIL C, which is a much lower requirement. So like A and B are like, are your headlights, to meet B for headlights or whatever, you can have 2 A-level headlights and now you have B, for example. So the lower the letter, the easier it is. So if it's ACell A, there's some safety element to it in a car. And with ACell D, it's like, oh, and if this messes up because we measure it wrong or we don't have a failure mode, and it will kill you. So ACell D is like you need to be designing for death. ACell C, which again is what my product is for, you know, it allows for major injury but not death, basically. So the way I get around not needing to spec for ACell D is that I don't allow people to park their vehicles in habitable space. So that's an attached garage, a parking garage with you know, apartment units above it or commercial space above it or whatever. My program requires that you park the car outside on the street in a garage that's not attached or, you know, wherever, just in a parking lot, but not in your attached garage in your house. Because when you have my product installed, it's above 10 kilowatt hours of energy. It's a lot of energy to release if one of these modules fail. Lastly, just because I'm on the sides of, you know, we're talking about lithium batteries here, I am so ready for solid state lithium cells. You know, we've had a lot of different tech over the years. You know, hybrids, modern hybrids started with nickel metal hydride, and until a few years ago, most of them, or a lot of them, still use them. Toyota really hung out there for a long time, but even they are mostly lithium now. Lithium iron phosphate, much safer than these lithium manganese or lithium cobalt cells or whatever. So these are not LFP, these are higher energy density. That's the problem with LFP. The energy density is just a lot lower. And in my opinion, there's not a lot of benefit to going from nickel metal hydride to LFP. There's just not that much energy density gained. You know, and so that's why most manufacturers in their higher end vehicles or their higher range vehicles are using, you know, lithium cobalt, lithium manganese oxide, you know, higher energy density things. All of those battery technologies will go away as soon as someone makes a viable commercial solid state, probably lithium battery, because those things are not going to explode. You know, they don't have the wet electrolyte that loves to burn and sustain a fire, and they will probably last for 50 years. But we are always 5 years away from that, so don't hold your breath. At some point, we will have solid state batteries, hopefully in my lifetime. We will see. Little off topic here, the whole end of this, and of course threw in some opinions as well. I'm sure people will argue with me about LFP over nickel metal hydride. It's just a lot of extra work for, you know, if you're going to do all the extra work for LFP, you go home and just do everything, you know, get that high energy density lithium manganese oxide or cobalt or, you know, whatever higher energy density cell. So yeah, that's about it. Sucks to kill a perfectly functional module, but I just had to look inside because I really wanted to understand this Boeing issue. And again, we have almost no guidance from Samsung, certainly nothing official, but it makes sense that these plates are Boeing. And I don't think Boeing, even up to like 1.5 millimeters that some members have reported, I just don't think that's problematic, having now looked at just how much pressure it takes to compress these. This is another don't do this at home thing, and we're going to take armor press again. Come here, buddy. And we're going to take this flat plate here, put it on the bottom, put our discharge cell here, and then we're going to take this top compression plate. This is not how it's actually compressed in the field because it's compressed from the side, but I just kind of want to get a feel for how much force it takes to make this thing flush again. I think it's probably going to be a lot. It's honestly not as much as I would have thought. I'm probably doing, that's probably around 300 or 400 pounds. It's really hard to tell with something like this that has so much mechanical advantage. I'm taking this tiny little gear and, you know, mashing this bar down. But I'm gonna say somewhere in the 300 to 400 pounds to get that thing to seat all the way. So yeah, that's gonna make a 1/4 inch thick aluminum plate that's 4 or 4.5 inches long. It's gonna make it flex. You got a bunch of those in series, but it really shouldn't increase the force that much because they're all just compressing in series, but it probably is. But it's probably not like, you know, when you have Belleville springs and you're putting a whole bunch of them parallel and it just adds up. That's not what's happening here. So anyway, that is, as always, a very long video because I don't make short videos, unfortunately. But if you are still watching, thank you for doing so. I don't really ever publish any of this to make money. And as soon as I have enough subscribers to turn on Google AdSense, my first plan of action is to disable advertising, which you can't actually do on YouTube until you have enough subscribers and view count. But as soon as that happens, I will turn ads off forever. A little pro tip here for anyone who's stuck it out. If you add a dash between the T and the U on any URL link, you can watch the video without ads. That's worked for me for years. Don't know who does it, but just wanted to throw that in there. If you want to watch a video, another neat thing with that, when you add the dash between the T and the U, it's ute-oob.com/whatever your URL was. You can literally just add the dash. Everything will work. If you do that, there are no ads. You can listen to albums. They repeat. The videos that you are playing that way repeat. So anyway, throw that in there for anyone who is curious. If enough people start using it, eventually it will stop working. But hasn't happened yet. It's been years. So little fun little Easter egg for everyone who stuck around till the end. As always, thanks for watching, and thanks for waiting through this recall with me, which is just completely disaster. But whatever, it's gonna hurt Samsung SDI more than it ultimately hurts me. And ultimately, you know, based on the data I have, I think that the risk is just higher that this is going to happen. So before, maybe it was 1 in 100,000. Now it's 1 in 8,400. I don't actually know that those are the numbers, but higher risk. To me, the worst case scenario, if you follow my instructions, is your car burns to the ground. And that's a horrible thing, but as long as that car is not in your garage, you know, it's a 25-year-old Jeep car. Obviously, I don't want to burn your car to the ground, and that's not my goal. Ooh, one final thing. Just because I had written about it. I hadn't actually even noticed it until right now. So this one, the end one here probably has it as well, but you can see this is that mechanical insulator. It's actually in their data sheet. And that's actually probably more than 1 millimeter of additional insulation there. My theory had been that because they have these cuts here for the insulator piece for the cables, my theory is that they had to add cuts here so that the stress concentrator, as this deflects, does not put a hard angle right here. That's my theory on why they've added this little dip there, but neat to kind of see that in the flesh. Let's see, this has a build date of 2019, August. So it's kind of an older module. Not too old, but anyway, thanks for watching.